This is part 2 of the 2.08 review, molarity and mole fractions. So again, this is from the problems book, and I just copy pasted them into Word so I could have it written up ahead of time for you. Question 1. A student dissolves 0.112 moles sucrose in enough water to make a 4.0 liter of solution. What is the molarity of the solution? What do you know? You know you have 0.112 moles of sucrose, you know you have 4.0 liters of water, and you know molarity is mole per liter. So what are we going to do? We're simply going to put the moles of sucrose over the total liters, divide it out, and we get an answer of 0.028 molar. Question number 2. How many moles of sodium hydroxide are in 1.5 liters of 0.2 molar NaOH solution? So again, what do you know? List everything that you know. I have 1.5 liters. I have a 0.2 molar solution, which is the same as saying 0.2 moles per liter. And I want to find how many moles. So start with what you know. We have 1.5 liters of solution. Put liters on the bottom of the next fraction so they cancel off. And we know that we have 0.2 moles per liter. So a big hint in this is when they give you the capital italicized M for a unit, I always rewrite it as moles per liter so that I have in my head that, okay, that's really what I have. I have moles and I have liters. And then, of course, your answer is 0.3 moles NaOH. Question number 3. A scientist mixes 5.23 moles of water, 1.14 moles methanol, and 0.893 moles of ethanol. What is the mole fraction of each substance in the solution? What do you know? So list them all out. And the total moles. So how many total moles do I have? What do? I have to add them all up together to get my total moles of 7.263. And if I want to know how much of each I have, what do I do now? I simply set up my fractions. So how many moles of water divided by the total moles? How many moles of ethanol divided by the total moles? How many moles of, that one was methanol. How many moles of ethanol divided by the total moles? If I add these up, it should equal 1, and that's just like if you made them all percentages, it would equal 100%. All right, let's go ahead to the next section, which is molality and mass percent. So I'm on page 146 of the problem set book, molality and mass percent. Molality and mass percent are two ways to express concentration of solution. Our objective is to use molality, mass percent, and volume percent to express the concentration of solution. Points to remember in the green column, molality and mass percent. The molality of a solute in solution is the number of moles of solute that are dissolved in 1 kilogram of the solvent. The denominator in a molality calculation is kilograms of solvent, not kilograms of solution. It's kilograms of solvent. The molality of a solution does not change with temperature. The mass percent of one component in a mixture is 100 times the ratio of the mass of that component in the mixture to the total mass of the mixture. The volume percent of one component in a mixture is 100 times the ratio of the volume of the component in the mixture to the total mass of the mixture. In other words, to make it a percent, you times by 100. Volume percent is most often used to describe the concentration of a mixture of liquids. Molality and mass percent are two ways to express the concentration of solution. Remember that molarity and mole fraction are two ways of expressing their concentration of a solution. Another common way to express solution concentration is molality, which is represented by the symbol lowercase italicized m. The molality of a solute in a solution is equal to the number of moles of the solute in 1 kilogram of solvent. The main advantage of using molality instead of molarity is that molality is temperature independent. Two other ways to express the concentration of a solution are mass percent and volume percent. The mass percent of any component in a mixture is equal to 100 times the mass of that component divided by the total mass of the mixture. Similarly, the volume percent of a component in a solution is equal to 100 times the volume of that component divided by the total volume of the mixture. Again, basically you multiply by 100 to get a percent. Mass percent and volume percent, like mole fraction, have no units. Example number 1. Calculate the molality of a solution. What is the molality of a solution made by dissolving 2.5 grams of table sugar, which is sucrose, in 50 mils of water at 4 degrees Celsius? The density of water at 4 degrees is 1.0 grams per milliliter. So strategize and collect. To calculate the molality of a solution, you must know the number of moles of solute and the mass of the solvent. Therefore, to solve this problem, first convert grams of sucrose to moles of sucrose, and milliliters of water to kilograms of water. The periodic table shows that the molar mass of sucrose is 342.3 grams per mole. Use molar mass as a conversion factor to convert grams to moles. So we started out with 2.5 grams, times it by the fact that there are 342.3 grams in each mole of sucrose, gives us an answer of 7.3 times 10 to the negative 3 moles. Next, use density as a conversion factor to convert milliliters to kilograms as shown below. So, 50 milliliters, we know that in 1 milliliter we have 1 gram of water. That's why they gave us the density. 1 gram of water is the same as 1 milliliter of water. Then we need to convert our grams into kilograms, and we get 0.05 kilograms of water. The molality of the solution is found by dividing the number of moles of solute, the sugar, by the number of kilograms of solvent, the water, as shown below. So we have our moles, 7.3 times 10 to the negative 3 moles, divided by 0.05 kilograms, gives us 0.146 molal, or moles per kilogram. Example 2. Calculate mass percent. A student dissolves 0.655 moles sucrose in 1.0 liters of water at 4 degrees Celsius. What is the mass percent of sucrose in the solution? The density of water at 4 degrees Celsius is 1 gram per milliliter. So again, collect and strategize. Use molar mass to convert moles to grams, and use density to convert liters to grams. The molar mass of sucrose is 342.3 grams per mole, so they got that from the periodic table. So the mass of sucrose in the solution can be calculated as shown below. We know that we started with 0.655 moles, put moles on the bottom of the next fraction, because 1 mole is equal to 342.3 grams of sucrose, gives us a total of 224 grams of sucrose. The mass of water can be calculated as follows. They gave us 1 liter. Then they converted it to milliliters because 1 milliliter is the same as a gram. So our answer is 1 times 10 to the third grams, or in other words, 1,000. Then solve. The total mass of the solution is the 1,000 plus 224. Remember, you got to add these together. Therefore, the mass percent of sucrose can be calculated by dividing the mass of the solute, the sucrose, the 224, by the total mass, and then you multiply it by 100 to get a percent. All right, and then there's 3 problems for us to go over. And again, I just copy-pasted them in Word so I could have it all filled out for you ahead of time. A student dissolves 0.25 moles of salt in 2.05 kilograms of water. What's the molality of the resulting solution? List what you know. We have 0.25 moles of salt. We have 2.05 kilograms of water. And we know molality is moles per kilogram. So what do? Just divide your moles by kilograms, and our answer is 0.122 molal, or moles per kilogram. A chemist dissolves 15.53 grams of sodium hydroxide in 0.75 kilograms of water. What is the mass percent of each component in the mixture? And it says, hint, make sure to check your units. What do I know? I have 15.53 grams of sodium hydroxide. I have 0.75 kilograms of water. Well, we need to change kilograms to grams, and 1,000 grams equals 1 kilogram. So, if you're not sure how to do these, set up a fraction. 0.05 kilograms times kilograms goes on the bottom of the next fraction, so it cancels. So you just times it by 1,000, you get 750 grams of water. So the total mass of the solution is 15.53 plus 750, or 7.5 times 10 to the second, gives us a total of 765.53 grams. Therefore, the mass percent of each component in the mixture is calculated as shown below. We take our mass of sodium hydroxide divided by the total times 100, gives us about 2%. Our mass of water divided by the total gives us about 98%. How do we check to make sure our answer is right? As a double check, make sure the percentages add up to 100. So they add up to 100.03, and which is like having 3 extra pennies, so basically close enough. And the last one, what is the mass percent of salt in a solution prepared by dissolving 1 mole of salt in 3.45 kilograms of water? And the hint, calculate the molar mass of sodium chloride. So what do we know? We have 1 mole of sodium chloride, 3.45 kilograms of water, and I want to find the mass percent of sodium chloride. And it said to find the molar mass of sodium chloride. All right, so then it says to calculate mass percent, you must first calculate the mass of salt in the solution. The periodic table shows that the molar mass of salt is 58.443 grams per mole. Therefore, the mass of 1 mole of sodium chloride is 58.443 grams. Next, convert the mass of water from kilograms to grams. So again, 1,000 grams is the same as 1 kilogram. 3.45 kilograms times 1,000 gives us 3,450 grams. The total mass of the solution, therefore, remember we got to add it, so we have to add up our 3,450 plus our 58.443, gives us a total mass of 3,508 grams. The mass percent of sodium chloride can be calculated as shown. Mass percent equals, put your mass of the sodium chloride on top over the total, times 100 gives you 1.67%. And that's all. So again, watch this again, hit that pause button, make sure you can do these all by yourself, and then double check your answer.